Hi, Naisha. How are you doing?
I'm fine. How are you?
Good, good. This is the year end, Naisha. Tell me some of your accomplishments of the year in the field of sports.
Yes, I have won many medals this year in exercises, different exercises types, and I have just won two silver medals and eight gold medals.
Two silver and eight gold medals? Wow.
Yes,
Very good. That's great. Well, let me add here that she was in bed 2 days before the competition, and when she got up, she scored gold. And now we are looking forward for a gold in mathematics. So,
yes.
Naisha, tell me, in your journey, how can I contribute? Journey towards the goal in mathematics. Now, today, what do you
Uh,
want to learn?
Today, first we have completed our first chapter in the portion.
Mhm.
Now, second chapter, which is
You can share the screen. Let me give you the opportunity. Yeah. Now you can share the
yes,
screen. Tell me.
just a minute.
And we
Can
have,
you see this?
yes, you have exam in January, right?
Yes,
And you have to get the best marks there also. Yes. Which chapter you
yes.
want to do today?
Today we can start with equations in one variable.
Okay, show me what all is there in this, and I will then look. So you can stop sharing your screen. We'll come back to this question later at the end of the class. Okay. So just keep this page. And now I will share my screen with you. The whole idea here is that you have to catch up a lot, right? Because you've been so interested in sports, which is, I'll say, the outdoor activities, you have lost a lot of the classes in and the opportunity of learn inside the class. And so you're way behind. So I'll start with basics today and take you to the level which is even higher than what you showed me. Is that okay? Because you can achieve much more. You see that. You can achieve much more. That's my philosophy. And we are going to work towards it. So let me share with you the lesson which I have actually prepared for you. And that's a wonderful lesson, uh, which you can see here. Well, actually, can you see my screen, Naisha?
Yes,
Great. So, what do you see? Can you read the title of this particular page?
yes. Algebraic expression and applications.
Yes. So, the idea is before we start solving word problems, we have to understand what the word problem is. So, we always begin by defining a variable. For example, in that question that you shared, my name was also there. Age related question, right? Age of Veru, age of Anil, and all these people. So, you will say, first thing, variable. Let age of Anil be X. You see that?
Yes,
Or you may say, let age of Anil be A, let age of Viru be V. You get the idea. So you define a variable. As soon as we define a variable, we are moving from arithmetic to algebra. Algebra is something where the operations are performed along with the variables. In arithmetic, we are only talking about the operation on numbers. You get the difference now?
yes,
So when we move from arithmetic, which is 2 times 3 plus 5 divided by something, all numbers included. 2, something like which we are talking about where the variables x and y come in, like 2x plus 3y equals to 10, for example, it becomes an algebraic equation all of a sudden because it involves variables. So we'll begin with understanding what arithmetic is, what algebra is, how do we define a variable. And now, when I write that Anil is half the age of someone, let's say Viru, for example, I'm just making up a question, then we have already defined a variable A for Anil, V for Viru. Then we say, well, Anil is half of Viru's age, is younger, that means V divided by 2. A is equal to V divided by 2, half the age of Viru. So we get an equation. Equation means there is an equal to sign in between, and on the sides, we have all those arithmetic operations with at least one variable in the whole equation. You get the idea. And
yes,
then the next step is how do we solve this question? Depending on all other conditions. After so many years, before so many years, that was the condition. We put that condition in. And since we know these two are related, we can actually solve the age of both the persons. That is the gist of answering algebraic or solving algebraic equations. But before that, let me look into all these things. So we'll talk about the journey from arithmetic to algebra. You see, that is what I explained you just now. The journey from arithmetic to algebra is introduction of variable in our calculations, correct? All the mathematical operations which you say order of operation, in that if I introduce a variable, it becomes algebraic expression. And that is the journey from arithmetic to algebra. And we'll now recall what are expressions, what are operations, what is the distributive property. You know all that, but we'll quickly go through it. And then we'll see some problem solving techniques. We learn all this before getting into solving word problems like you shared with me. Is that okay? So,
Yes.
what do you recall? Can you please read the screen?
Yes. Arithmetic to algebra. Arithmetic is a branch of mathematics that deals with what is the difference
That
between
deals with
numbers
what?
and
Tell me. That deals with what? Arithmetic is branch of mathematics that deals with numbers and operations. You see, that deals with dot
numbers and
numbers and operations. Right. Next question for you. What is the difference between numerals and variables? So when we talk about variables, we also have numerals, right? So that is another good question to answer. And now the question is, what is the difference between pronumerals and variables? These are different terms which we are going to use as we move along. Is that okay? Correct? So I will take you to the definitions themselves so that we understand all these terms fairly well. You get the idea, right? So, key definition. What is a variable? Variable is a symbol used to represent unspecified quantity or value. That means variable can have any value, but we have not specified any. You get the point? Anil's age could be anything. You don't know, right? So
yes.
x is a variable means that it represents unspecified quantity or value. It may or may not have any particular value, but depending on the situation, it could have any value. You get the idea? That is a variable.
Yes.
We also come across a word, pronumeral. Pronumeral is a symbol that represents a particular number. For example, pi. You have come across pi. You know what pi is?
Yes.
3.14, as you say. So pi is a pronumeral. You get the idea? It has a value, but we use it as a variable symbol. You understand? So it's not exactly a variable because it is a constant value. Do you understand the difference between the two now? Variable and pronumeral?
Yes.
Variable value is not specified. Pronumeral value is specified. You get the idea?
Yes.
And as we move along, let me tell you one more thing. Pi is very interesting, and exact value of pi is what? It is circumference over diameter, right?
Yes.
So you know circumference is pi times the diameter, right? D. And if you divide by diameter D, it cancels and you get pi. You see that? So pi is defined as the ratio of circumference to diameter, and it is approximately equal to 3.14, right? Or 22 by, or we sometimes write 22 by 7 for our easy calculation. Is that okay? So that is what pi is. And pi is a pronumeral. Do you understand pi now? So difference between variable has no fixed value. However, pronumeral has a fixed value, right? Now, I teach globally, and therefore my approach is to teach you all what is related and how we see it in different parts of the world. You get the idea, right? So you might, this may be a new term for you, but this is very important term for you. Is it okay? Now, let's move on and see what algebra is. Now, algebra is the branch of mathematics that deals with variables, numbers, and various operations on them. Correct?
Yes.
From here, you see that the common factor is numbers and various operations between algebra and arithmetic. Correct? But as soon as we get variables involved, it becomes algebra. You get the idea?
Yes.
Okay. So many times students, I come across high school students or middle school students, they say, well, I was very good in math, But as soon as algebra was introduced, I kind of couldn't catch up. You get the idea? Because as soon as the algebra was introduced, it was introduction to the new era of variables, which was not properly, understood because of whatsoever reason. Correct? So that is why stepping from arithmetic to algebra can be a problem at times. Now, next thing which we look into is an algebraic expression. An algebraic expression is combination of sum and or product of numbers and variables. So here we have an expression, as you can see, 3x squared minus x plus 5. This is an algebraic expression. It has operators. The operators are 3 times x squared minus and plus. These are the operators. We have variable, which is x in it. We have numbers, which is 3, 1, and 5. When I write only x, it is being multiplied by number 1. You get the idea? So number 1
Yes.
is intrinsic. It is there. You cannot see it. You get the idea. So 1 is also there. Good. So we have 3 terms. Independently, this is our first term, second term, and third term. This is an expression with 3 terms, right? You learn polynomials, and in polynomials, you could have many terms. So that is how it comes. Okay? Is this clear to you?
Yes.
So once again, algebraic expression is combination of sum and a product of numbers and variables. It can have one or more terms separated by addition, subtraction operators. So these terms are separated by addition and subtraction operators, correct?
Yes.
As shown here. Now, another good term to know is what is a verbal expression? Verbal expression, like in English, we have, right? Is an algebraic expression that is expressed in words, like 2 more than 5. So you know the number 2 more than 5 will be 7, correct? But when we talk about algebra, so 2 more than a number. So when I say 2 more than a number is n. N plus 2 is my answer. So that is an algebraic expression, since I have introduced you to a variable which is n. You get the idea?
Yes.
Correct. So what we saw here in the previous case, that there are terms, and the terms are 3x squared minus x and 5. Correct? Now verbal expression, 3 times x squared minus 5. 3 times x squared minus 5. So it will be written as 3x squared minus 5. You get the idea? So
Yes.
3 times x squared minus 5 will be written 3 times x squared minus 5. It makes sense to you, correct? So this is what we are saying, verbal expression. It helps you to understand a word problem. We are actually breaking the word problem into small phrases and sentences and then linking them together, correct? Now, when I use the word
Yes.
phrase, in that case, phrase is for an expression and sentence is for an equation, right? So we say, when I say 3x squared minus 5 is equal to, let us say, 27 or something like this, right? Then we have an equation because we have given it a value. Is that clear to you?
Yes.
Okay. Now, again, we'll talk about terms which we already talked about. Term of an expression can be a number. So in this case, 5 is a number and it is also a term. A variable, just x, is also a term. Or product of numbers and variables, 3x squared. You get the idea. 3x squared is 3xx. So product of xx, which is x squared, correct? So product of numbers and variables. So when I say 3x squared, I really means product of 3x and x. You see that? So this is what a term is. Now another very important related thing to learn is coefficient. Coefficient of a term is a numerical factor, right? So factor when you multiply two things. So when we have 3x squared, then 3 is coefficient of x squared. You see the number in a term, numerical factor. So 3 is coefficient of x squared. You get the idea?
Yes.
So what is the coefficient of minus x? If I have minus x, the coefficient is minus 1. Do you see this number? 1 is not
Yes.
2, minus 1. Okay, so with this in mind, let's move forward and take up some algebraic expressions. Now, this is an exercise for you. We have some verbal expressions for you. So verbal expression is an algebraic expression that is expressed in words, correct? Now here's an example. If the expression is z plus 1, tell me in words, how will you write this expression? Where z will be a number, correct? So you can say 1 more than a number, correct? So z plus 1 is 1 more than number, correct? What is x minus 3? 3 less than number. You get the idea? X minus 3 is 3 less than number. 7 minus n over 3 is what? From 7, take away 1/3 of a number. You get the idea?
I'm a bit confused, or like I can't understand properly, like what, how we have to clarify this.
Okay. So in this exercise, what we are going to do is we are going to take verbal expressions. Now, verbal expressions is an algebraic expression that is expressed in words. So we have these, all the variables here represent some kind of number, right? So variables represent some number, okay?
Yes.
We have not given any fixed number to it, any number. So all those things which we talk about in this expression involves two things, variables and numbers. But variables are also kind of numbers, right? They don't have a fixed value. So variables represent some numbers, and when we have verbal expression, it means it is a phrase. So we have to write phrase here, right? What does this expression mean? This is verbal expression. So when I say z plus 1, z is a number, right? So we say z plus 1 really means what? We can write this as 1 more than a number. Do you see that? We don't know 1 more than which number. Therefore, it is a variable. Do you see that? And in this
Yes.
case, we are calling this variable as z. So I just gave you the name. Does it make sense to you?
Yes.
We can write it in many different ways. 1 more than a number, or add 1 to the number. We can also say add 1 to the number, correct?
Yes.
So we could write this in many different ways. Similarly, how will you say x minus 3 as a phrase? Can you write down? Can you tell me? Verbal expression.
Just a second. Just a second. I have to take it. Sorry.
Yes. So now, can you please tell me how will you write x minus 3, which is a verbal expression in terms of words or a phrase? We can say words.
3 more than the number of x.
No, x minus 3 I'm talking about. So 3 less than. So we got 3 less than number.
Okay. 3 less than the number of x.
Number. And where we are saying representing number with x. So that is, you could say any other alphabet, but in this case we have used it. It doesn't make sense, right?
Yes.
So likewise, we could actually give them some names. And let me just show you how we have given these names here. So that will give you an idea how to translate verbal expressions into the words. That will help you to understand a word problem, correct? Because in word problem, we had so many years more than, then you should know how can we write it in algebra, right? So
Yes.
that becomes the foundation. So can you please, I'll just read it out for you. For example, z plus 1 is 1 more than a number, right? You understand? So what is z
Yes.
plus 1? 1 more than a number. X minus 3, 3 less than a number. Do you see minus 3 is coming later? So, but we are saying 3 less than a number. Number comes first. So number is the principle. That is how we are. Now 7 minus n over 3. So minus, I could also say in a different way. 7 decreased by the quotient of n and 3. So use the word quotient. Do you understand quotient now? In
Yes.
division of polynomials, you said quotient, right? So quotient means, like we are saying, quotient of n over 3. So when you divide two things, we call that as a quotient. Is it okay?
Quotient. Yes.
Correct. And then we have pi r square h. It is a very, we know this pi r square h is a formula, but how will you describe it? Pi times r squared multiplied by h. That is how it is described in words. Is that clear to you?
Yes.
X plus 1 over x. Now 1 over x is the reciprocal of x. You understand the word reciprocal? Reciprocal is 1 over x. So let's learn new terms also. When we say reciprocal of x is 1 over x. Do you understand? For example, if I have 5, in that case 1 over 5 is the reciprocal. And what is the important property here? If you multiply 5 and reciprocal, what do you get? You get the number 1, correct? Similarly, if I multiply x with 1 over x, they cancel and I get 1. So when you have these two expressions or the numbers, which when multiplied gives you 1, then they are reciprocal of one another. You get the idea?
Yes.
Very important concept. I'm actually preparing you for much higher studies now. Now you understand these terms from a grade 9 or grade 10 student's perspective. So P over Q, as I told you, is a quotient of P and Q, or ratio of P and Q. So when in your question you have ratio of these two items is 2:3, you will write 2 over 3 or 2:3. You can see P over Q is 2:3, correct?
Yes.
Now, if I have something like this, that means I'm multiplying two expressions, and it's called product of consecutive numbers. Now, you understand what are consecutive numbers?
No.
Consecutive numbers are numbers which come one after the other. So, for example, if I say 3, 4, 5, 6, do you see these numbers?
Yes.
They are consecutive.
Okay.
So, you see that any number is one more than previous number, correct? Then it is consecutive. They come together in the number system, correct? So
Yes.
4, what is 4? So 4 equals to 3 plus 1, correct? And 5 is equals to 4 plus 1. Do you see that? So
Yes.
when I say x is one number, then x plus 1 is the other number, correct?
Yes.
And what are we writing? We are writing product of. Product means they will be multiplied. So I'm multiplying x with x plus 1. Do you get the idea?
Yes.
I was looking into your series and there was a question based on consecutive numbers before the
Okay.
example where we start. So it is a very important expression, and you need to understand when we say consecutive numbers, it really means that x is one number and x plus 1 is the other number, correct?
Yes.
X minus 1 could be also written because 3 is 1 less than 4, and 3 and 4 are consecutive numbers, correct? So sometimes we will use that also concept. Is that clear to you? Consecutive numbers. We'll look into this more in times to come. Now, we have an expression which is 2x squared minus 1. How are you saying it in words? 2 times x to the second power minus 1. 2 times x squared also you could say. You could say 2 times x to the second power minus 1. That is how you're going to read this expression in words. Is that clear to you?
Yes.
This requires a lot of practice. It seems to be easy. So when I upload this video, you have to watch it and understand how we have explained each term. And then we have 2 over 3 p squared, which means 2/3 of a square. 2/3 of the square of a number, p squared. So p is a variable, a number whose square, p squared. You understand? So 2/3 of p squared. You get the idea?
Yes.
Similarly, we have many other expressions. So the last two, x minus 1 times 5 could be written as product of, because you multiply, we say a product of 1 less than a number. 1 less than number is x minus 1 and 5. You get the idea? Product
Yes.
of x minus 1 is 1 less than a number times 5. So we have combined words within words and make it more complex. Next one, last one for you. 6 times x to the power of 4 plus 1. 6 times sum of number to the fourth power. Sum of number to the fourth power plus 1. Do you see that? And 1. So when I use this, 6 times, this thing comes in bracket. 6 times sum of number to the fourth power and 1. You get the idea. So when you do that operation, it comes in the bracket by times 6. Very complicated. So that is what it is. And here is your first exercise. I'm just leaving this as your homework. What you need to do is write down all these phrases and then I'll check your homework. Is that okay now? So on the video,
Yes.
when you come at this particular stage, you should pause the video, fill up this column just as we did before. And that is a key for you, right? So these are all my examples so that you could actually do your exercise. So that will help you to understand. And if there are things which are complicated, you have to get back to me. I'll explain you those things. Is that clear to you?
Yes.
Perfect. So now we have seen many things while converting verbal expressions into words, or more important, words to verbal expression. So these two things are intermixed. And what kind of phrases do we use? Do you see this table here? This table is going to really help you to do your exercise. We have operations. When we say operations, we talk about addition, subtraction, multiplication, division, exponent, right?
Yes.
Consecutive numbers, one after the other, which is written as x times x plus 1 as a product and equal to sign. So these are the different operations. When you have equal to sign, you have written an equation. Without equal to sign, it is an expression. Is this clear to you?
Yes.
Now, plus means sum, plus addition, more than, add to, increased by. So if I have these terms in my phrase, that the distance is increased by 2 kilometers, that means d plus 2, right? My age is 5 more than Atul's age, then Atul plus 5 is my age, right? A plus 5. So that is how we use addition. Subtraction, you understand, 5 less than a number, right? Multiplication is written as a product or multiplied by or times of. So many times this is this, correct? So
Yes.
many times. N number of times x is y. So that becomes an equation. Division, exponents. This is translation of the two things, operations and word phrases. Is this clear to you?
Yes.
Now, we are getting into the next exercise where I give you the phrases. You have to write the expression. For example, 1 more than 7 times a number. How will you write this expression? Tell me. 1 more than 7 times a number. Now, let's
Can I
read.
annotate?
Example 2. Write algebraic expression for the following verbal expressions. Let the variables be n, a, and b represent numbers. Use these variables n, a, and b, any one of them, right? So when you say a number, you can use n. You can also use a and b. So in the first one, when I say 1 more than 7 times a number, how will I write this as an expression? Can you write down? Tell me. 1 more than 7 times a number. How will you write?
Write like 7 is a variable in this.
Variable is n. Okay, use n as a variable. So 1 more than 7 times a number. So what is 7 times?
7 is n.
7n is 7 times n. 1 more
Yes.
than. When I say 1 more than, then write plus 1
Plus
n.
1. Yes.
Is this clear to you?
Yes.
Double a number less 5. Double a number less 5. How will you write this? Double a number
Just
2n less 5. Does it make sense? So double a number less 5. Is this clear to
5.
you? Next,
Yes.
3 less than square of a number. So first you write square of a number and then you take away
Yes.
3. So 3
3.
less than square of a number. Quotient of 12 and number plus 5. Quotient of 12, so 12 comes on top
12
and
n.
number 12 over n. So it is divided when I say quotient of n plus 5. Does it make sense?
Yes. Yes.
That is what I'm trying to say. And here is the solution of all this for you. So what you need to do is when you run this video once again, pause the video at this stage and see how we are converting these expressions in words into algebraic expression. That is your first exercise. Before getting into word problems, all these concepts should be absolutely clear. Otherwise, during the whole life in school, you'll be struggling to solve word problems. This is the key to solving word problems. Is that clear to you?
Yes.
Once you do this exercise, here is another exercise for you. You are a sports person, right? Warm up. Those
Yes.
were warm up. You have to really work very hard to reach to that goal. You get the idea? You have to work hard.
Yes.
Just as I'm working hard for you. Do you see how many examples I have for you right there? Now, work on these things and fill all this. When I say 3 less than 4 times the number, it means 4 times the number and then 3. And so continue. It is not 3 minus 4n. Do not make that mistake. 3 less than 4 times the number. If you write 3 minus 4n, it will be wrong. Well, look at the word than. Than means 3 less than that. So that will come first and then 3 will come. Is this clear to you? Very common
Yes.
mistake performed by so many students and they lose that mark of being on the top. Is that clear to you? So you
Yes.
have to work on this exercise and that will conclude the first part of our lesson today, which is how do we relate words to algebraic expressions, right? Now let's move forward. And we have one more very important property which you know about, distributive property. So this helps you to simplify the expressions. So now we are getting into the part which we say, how do we simplify expressions? So we know now how do we write expressions, and now we are looking into how do we simplify. One of the most complicated example is or performance operation is the distributive property. When I multiply, these are my variables A, B, and C. And when I multiply A with something in bracket, which is in this case B plus C, then A gets multiplied with everything inside the bracket. So A gets multiplied with B and A also gets multiplied with C. The result is AB plus AC, correct? With
Yes.
polynomials, when you did, you were doing the same operation. If it is B minus C, you get AB minus AC. So that is what the distributive property is. What I've done here as an example is I have taken some numbers for the variables. Numbers can take any variable number, right? So variable can take any number. So we have taken 5, 2, and 4 as the numbers for A, B, and C. So when you perform that, you see the left-hand side. What is 5 times 2 plus 4? You will do inside operation first. That is the order of operation, correct? So 2 plus 4 is 6. And when you multiply 6 with 5, you get 30, correct?
30.
On the
Yes.
right hand side, I have written AB plus AC. That means multiplying 5 with 2 and then 5 with 4. So when I do multiplication, it is 5 times 2 plus 5 times 4. 5
4.
times 2 is 10. 5 times 4 is 20. When you add, you get 30. Left
30.
side is equal to right side. That means this becomes an identity. So these are our identities. Do you understand? They are true always. Is that clear to you?
Yes.
So what we call as a distributive property, A times within brackets B plus C is equals to AB plus AC is also an identity because it is true for all the values of A, B, and C. Is that clear to you, right? So there is another extended example which you have to watch during the video and understand. If not understood, you have to call me, text me, send an email, or write a comment on this particular video. Is that clear to you?
Yes.
Correct. Now we will take up examples, which are, we are slowly moving towards difficult word problems. Do you see that? But
Yes.
I'm giving you a picture also because you're an outdoor person. You like to see things, correct? And visualize. So here is a visual lesson on you. Today's lesson is totally visual. It is not a bookish lesson from any book. Is that clear to you?
Yes.
So this example is really based on the property which we just discussed. It is called distributive property.
Okay.
So here we have an example where we have a geometric representation of the property.
Yes.
Bless you. Okay. Now the question here is explain how the geometric representation of rectangles prove the distributive property A times B plus C is AB plus AC. Okay, so we will show geometrically how a times b plus c is ab plus ac. So see here a model. Do you see this a has one side of a rectangle, correct?
Yes.
On the other side, I have b plus c. So I have a rectangle whose length is a and b plus c, length and width. Do you see that?
Yes.
So I could say, well, this much length from here to here is b, and then we have another length c. Correct? Think about putting up a fence in your garden. One side is a length long, then second fence is b, and third is c. So you got these c's. But using this, how much area do you enclose? Find the area. Area enclosed. So area is constant. So when you have a times b, then this area is how much? AB. Do you see that?
Yes.
And how about the other area? A times c?
AC.
AC. So the combination of area is AB plus AC. Do you see that?
Yes.
On the other side, if I use length into width, you know what is area? Area is length into width, correct? So what is the length?
Yes.
Length is A, right? And how much is the width?
B plus C.
Do you see both are equal?
Yes.
So with this model, very simply, I have shown you how I can relate visually distributive property. Do you see that?
Yes.
That is a practical example, and I hope with this visual aid, you're never going to forget about it. Okay, so now here is a more complicated question for my sports girl, the golden girl. Yes, tell me, what have I done here? What are the two things which I'm relating? What is the length? I'm talking about area. So area is basically length into width, correct?
Yes.
Okay, you can say what is the length? You want to call this as a length? So let's say x plus 3. Is that okay?
Yes.
And that's the width, correct? Times
Yes.
x plus 1. Now, what is this equal to? It is equal to sum of all these areas. Do you see this? X times x is
Yes.
x squared, x times 1. So this is, when I say x plus 3, it means this is x, this is 1, this is 1, this is 1, correct? And this
Yes.
is x and this is 1. So when I multiply x and x, I get x squared. When I multiply x with 1, I get x with 1, I get x with 1. Area is length into width. So big rectangle area is sum of all the small rectangle area, right?
Yes.
Is that clear? When I use three lines, it means it is always true, correct? Equal to is equal to, but 3, when I write congruent, exactly same. Do you see that? Next chapter
Yes.
is congruent, and therefore I'm introducing to you this symbol congruent. Do you understand?
Yes.
So we are actually bridging the gap. I just saw the next chapter and I thought, let me introduce it just now. Okay, so the area is combine all this. What do you get? You get 1x squared, correct? How many x's? 1, 2, 3, 4 x's, correct?
Yes.
How many ones? 1, 2, 3 plus 3. Do you see that? We have expanded x plus 3 into x plus 1 directly from our model. We know we can perform the distributive property and get this result. Does it make sense to you?
Just a second. Can you just repeat? After that, I didn't hear you properly. After we
Okay,
expanded the x plus 3 and x plus 1, I didn't hear you.
okay. So let me erase this, right? Let me clear this and I'll do it all over again so that it becomes absolutely clear. We don't wait.
No, no, I've understood till we got the answer.
Okay, so let me repeat this. So if I do it distributive property, I get x times x and x times 1. So x times x is x squared, correct? X times 1 is x, correct? Now,
Yes.
if I multiply with 3, I get 3x, and then with 3, I get plus 3, correct? So when you combine, these are the like terms, you get x squared plus 3 plus 1 is 4x, and then you get plus 3, correct? So you could use distributive property to expand, correct?
Yes.
Now see, we'll now do this using the model.
Yes, I have understood with the
Model, we get what? We have this on the side. So inside is x squared. So there's 1x squared, correct? How many x's?
yes.
1, 2,
1,
3,
2, 3,
4. So 4x.
4.
How many ones? 1, 2,
1,
3.
2, 3. So we got 3.
Do you see both of them are same?
Yes.
You see the advantage. When we look at the model, we can immediately derive the result. We do not have to do these steps.
Yes.
That is visual learning. So from the model, we get immediate idea how the things could work out. And therefore, in mathematics, many times we actually make a model to solve our questions. This is a fantastic approach. Okay?
Yes.
Fine. Now, let's look into the other part of distributive property. How is distributive property helping us? Okay, we know the distributive property is what? A times B plus C is sum of AB and AC. But A times B minus C will be difference of AB and AC. Now, if I tell you multiply 8 times 61, how can you do it? So you will do like this, right? We have 61 and you'll multiply by 8. And you see 8 times 1 is 8 and 8 times 6 is 48, correct? And you get your answer.
Yes.
Now see here what I have done. I have written 61 as equal to 60 plus 1, correct?
Yes.
So when I'm multiplying 8 with 61, I'm multiplying 8 with 60 plus 1. And now it becomes easy. I have to multiply 8 with 60 and then 8 with 1. So 6 times 8 is 48 and then 10 and plus 8 gives me the same result, 488. Do you see that?
Yes.
It makes mental calculations very fast. You see, if I do 7 times 89, 89 is 90 minus 1. And so I can also do this operation very easily as shown here. Do you get the idea?
Yes.
Application of
Yes.
distributive property. I'm moving along. You need to watch this video and then understand all these concepts. And then after you understand the concept, this is again your practice test questions, and I'll call this as a homework for you. So do them and submit your homework to me, right? Send an email with the scanned copies of your homework. Okay, is this clear to you?
Yes.
Now, we look into the geometric property which we learn. So here is your homework on the geometric properties. So if I write x times x plus 3, it means what for you, correct? You have to write down the answer. Here, you see, I have two polynomial expressions. What am I doing in this case? As you can see, I am doing x plus y times a plus b. You see that? And what do I get? I get sum of all these. You see that? This
Yes.
is equals to xa plus xb plus ya plus yb. And that is general. And based on this, there are two questions. You have to now read the question. Sketch geometric representation means a model like this, rectangle. Do you understand? So I want you to sketch rectangles here, right?
Like I have to draw the same triangle structure here.
Yes. As a form
Not
of
the sum.
area. Yes. So area model. You
I have
understand?
to do like solving the sum, like how we found out the area like that.
Yeah. So there are
Okay.
two different questions. Question number 6 is explain how the given figure illustrates a distributive property. So you will explain like this how it represents a distributive property by expansion, correct? As we did
Yes.
in the previous case. And in this case, sketch geometric representation of the following expression. So you have to now sketch this kind of a thing for 2x plus 1. So you can write 2x, x, x. 2x means what? X, x, and 1. Do you see that? So this is x,
Yes.
this is x, and this is 2x. And 3 means 1, 2, and 3, right? So you get this rectangle. Do you see that?
Yes.
And then you can draw these and you have your solution. You get the idea. So that is how
Yes.
you're going to do it. Draw the model. It should be interesting for you. Okay, let's move on. So here we have combination of like terms. Previously, you saw we added like x plus x is 2x. That is how we combine the like terms. Now here the concept is like terms are the terms that have same combination of variables. These terms can be combined to simplify the expression. Example 7. Identify and combine the like terms. So in this case, do we have any like terms? 5x squared, 2x and minus 3?
Yes, x terms.
No, no. A like term x is like apples and x square is like bananas. So they are not the same things. So when we say like terms, that means they have same combination of variables and they're multiple, same combination of variables. So variable is x squared. X is squared, a combination of variables. X is a common variable, but the combination is x squared. Do you see that? So there are no
Yes.
like terms in this case. Okay. So anyway, what we are going to do is we are going to start from here in our next class. Okay. So for now, we have understood about working with our numbers, and basically what we completed today is the first part, which is verbal expressions for algebraic expressions, right? And we also saw operations of verbal expressions. And then we had algebraic expressions from verbal expressions, converting them. And we also understood the distributive property. And we have done application of distributive property, correct?
Yes.
We had a problem solving technique, which you have seen in the form of a model. So we have done all these parts. And now from here, we'll move forward in the next class. Is that okay? So we
Yes.
completed this model today, which is a very important critical part of learning. So we are going to end our lesson today at this particular stage. Did you understand everything?
Yes.
So I'll stop sharing the screen. Can you summarize what did you learn today?
Yes. I can summarize what we learned today.
Yeah.
Today we learned about how to simplify a triangle, like how what we have learned, how to explain it in the form of sum, like 3 times 1 is 3, like that. In that form, we have solved the sum, and then we have learned about how like various names of the signs and like plus have addition, like that. And then we have learned about how to draw the
Model.
geometric construction model. Yes.
For distributive
Yes.
law. Correct. So
Property.
you're right.
Yes.
So we learned starting from what is arithmetic, what is algebra, how are they different. Introduction of variables is algebra. Now we also learned how can you write a word into a rather word will be in this case a variable. And how do you write a phrase into an expression, a sentence into an equation? How do you simplify these expressions? How do you work with them? We're using distributive property, and we also saw the model for relating the algebraic expression in the form of distributive property into a geometric form of area of a rectangle, correct? Now, from here,
Yes.
we'll continue and see how do we solve and simplify expressions and then move on to the algebraic equations and their solutions in the next class. Is that clear to you?
Yes.
So you have a sound foundation of algebra to begin with. And then from here, we are going to go straight up and solve very difficult examples like what we see in your book. Is that clear to you? And we'll
Yes.
go way beyond that in our next class. Okay? Thank you and all the best.
Bye.
Bye.